Hi viewers, welcome to LMS Solution. Today we are going to see about neural network based fault tolerant system for cascaded multi-level inverters in MATLAB. So first I am going to explain about the basic concept, how we are going to implement the fault tolerant system in the cascaded multi-level inverter. Here we are going to use 50 level cascaded multi-level inverter. So for 15 level cascading output, we need 7 H bridge 1, 2, 3, 4, 5, 6, and 7. Here, fault in the cascade and multi-level inverter when we consider as inverter failure, switch failure, or battery failure, or known as DC source failure. So this is when we consider as a inverter failure. This need to be detected by means of neural network. After detection of that fault in the cascade and multi-level inverter, we need to generate the standard voltage based upon some corrective actions. For that, here we are going to use auxiliary H-bridge inverter. This auxiliary H-bridge inverter going to be added in the cascaded multi-level inverter during fault condition. So after fault condition, the neural network going to be detect the fault. So after fault detection, we are going to include that mean this auxiliary inverter in the system in order to make continuous power supply to the load. So what happened here? You can see that this is a 15 level output during normal operation. When any fault occur in the system, that means a multi-level inverter like inverter failure or switch failure, what happened? The level going to be reduced in the output voltage. So this will be create the problem in the load side. So we need to provide 1 per unit voltage to the load always. For that only we are going to use that fault tolerant system by using this auxiliary multi-level inverter. During normal operation, here we are using two switch. The SA1 equal to 1 and SA2 equal to 0. This is not connected with the system during normal operation. When the fault occur, the SA1 equal to 0, SA2 equal to 1. What happen? It going to be included in the system, and also you need to provide switching logic based upon where the fault is occur. Here there are 7 H-bridge inverter. So we need to find which H-bridge inverter having fault. Based upon that logic, we need to provide sequence switching sequence for this inverter in order to get the 15 level output in the load side. In order to detect the fault, so here you need to measure 8 quantities. One is voltage across each H bridge. So to measure voltage across each H bridge and then voltage across the inverter, or else we can call it as load. So this is going to be taken as the data. That means for normal condition, for fault condition in the each H bridge, you have to collect the data. This eight data. So based upon this 8 data, we need to train the neural networks. That neural network will be what based upon this data we are getting. How we are going to do that once in the MATLAB. This is a model created for the system. It consists of 7 H A1, A2, A3, A4, A5, A6, and A7, each having H bridge. Just you click inside, you will get see the H bridge. For fault creation, here we are using ideal switch is connected with the constant. The constant equal to 1 means the here known as is operated in normal condition. When here is this constant equal to 0 means so there is the problem in the for fault creation we created like that the constant is connected with its toggle switch. When on and off, the fault will be created in the system. And also here we have auxiliary H bridge. So this is going to be connected with system during that fault condition. The remaining time it will be not connected with this. Here you have to measure the voltage across each H bridge and the voltage across the load. This will be taken as the input neural network input. This data going to be collected for normal operation. Just you have to create the fault MB each H bridge and then you have to collect it. Already we collect the data. Here you can see that this is a single set of data collected from that system for different operation under normal condition fault in the each H bridge. So these are data collected from the system, and this data having only 60 data not enough for a neural network. So I'm going to take the 10 times of this data. That means 10 sets. I'm going to take the same kind of sets for the 10 times. So here you can see the data and I take the same set of data for 10 times. Why we are taking normally neural network need more number of training data, then only it will be trained well. Data again is the input data. Here we're going to create the output data. Here I'm going to take the number from 0 to 7. 0 indicate it's a normal operation. 1, 2, 3, 4, 5, 6, 7 indicate the fault in the corresponding H. For example, we consider number 3 means the fault is occur in the third H bridge. If number is 6 means the fault is occur in the sixth H bridge. For that, I create the data by my own for understanding, for classification. So next I'm going to use NL star for training process. I'm going to just go to type NL star and then click fitting app. You will see this window. So you go to click next, you go to feed the input data NL, and then next you go to feed the output data, and then you go to change to matrix source. You will get the 160 data. Click next, click next, click next. Now we go to train the neural network. Just you go to train the neural network, and then you can see the value of R, right? R should be equal to 1 for some meaning. Our collected data and the trained data both are having similar response. So next, click next, next, and then click simulating diagram. Here you have that trained neural network, this one. We can use this neural network for detection of fault in the Cascaded Multilevel Inverter. Next, that the model is used here, already trained model. It receives the same input, right? Voltage of each attribute under overall voltage across the load. It will provide the result in between 0, it will provide 0, 1, 2, 3 up to 7. And then based upon this value, fault detection, right? Fault detection value. So I'm going to turn on this 2 switch. I'm going to add this inverter to the Cascaded Multilevel Inverter based upon the condition getting from the inverter. It will be that when fault is detected means it will be generate 0 for here and 1 for here. For this switch, automatically this inverter going to be added in the system. For that, we are created some simple logic here, like logical operation and the inversion operation. And also based upon this detection logic, we are going to select the switching sequence. So because, for example, fault occur in the H bridge 1, we need to operate this auxiliary H bridge with the switching sequence of H bridge 1. So for that, we used multi-port concept for selecting the switching sequence based upon the fault in the H bridge. That will be done by means of this multi-port concept. So next, I'm going to simulate the model and then I'm going to explain the results. Initially, each H bridge will be linked with that means the fault concept being linked with a toggle switch. Toggle switch will be is on means there is no problem in the H bridge. If it is off means the problem, that means failure occur in the system. Now I'm going to simulate this one. Now all toggles which will be in on condition, system operate under normal. You will see that 15 level output, that means the load receiving the 15 level output. Now I'm going to create the fault in the H bridge 1 and then we will see the results. Now we can see that the fault is occur in the H bridge 1 because of the what happened, the reduction is occur in the system. This is automatically detected by means of neural network. That means here the result will be 1. What's the meaning? The fault occur in the H bridge 1. Because of that, this auxiliary inverter is connected to the system. Now you can see here we are getting 15 level output only. We are getting 15 level output without changing the waveform structure. Load continuously get the rated voltage. The fault is the tolerance system work fine for the fault in the H bridge. Same way I'm going to create the fault in the bridge H bridge 2 and we will see the results. Here also you can see that fault occur in the H bridge 2 because of that reduction in the level that going to be detected by means of neural network here. Here you can see that the value is 2. That means the fault occur in the bridge 2. Here the after that what happened, the auxiliary inverter is connected to the system. Because of that you are getting 15 level output from the inverter. The load continuously getting the continuous power supply with the rated value. So next time you want to create the fault in the H bridge 3 and then we will check the results. Now I'm going to create the fault in the H bridge 3 and then we are going to see the results. Here you can see that level reduction fault is detected by neural network, auxiliary inverter added. Because of that we are getting the 15 level output in the load side. Load continuously having the rated voltage. So next I'm going to create a fault in the H bridge 4 and then we have to check the results. Because of that what happened, the structure is changed in the system. Because of fault, what's the level structure changed. Here the fault is detected, auxiliary inverter is connected to the system. So we are getting the 15 level output rated voltage in the load side. Next I'm going to create the fault in the H bridge 5 and create the fault in the H bridge 5. Here also you can see that there is alteration in the level structure or that in waveform structure, fault is detected in the system. Because of fault detection, auxiliary inverter is added in the system. The level in the cell is maintained at 15 level. Next time we are going to create fault in the 6. Here you can see that the fault, because of fault, the level is reduced. Here the fault is detected in the neural network. Auxiliary inverter is added in the system. Because of that, the 15 level is maintained in this system. The next time we are going to add fault in the H-bridge 7, and then we will check the detection and the fault tolerant operation in the system. Here you can see that because of fault, the level is reduced. The fault is detected in the system. Auxiliary inverter is added in the system. The fault, that means system having 15 level output in the load side after fault detection, and that means the fault is automatically tolerated by the our developers. So this is the working of neural network based fault tolerance system for cascaded multi-level inverter. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon and turn on notification for notification about upcoming videos. Thank you so much. Bye bye.